Alright, in this lesson, we're going to be looking at the vertical stretch and shrink of graphs. We're going to be looking at how we can raise a graph, make it taller, or shrink it down, make it shorter. Our objectives are to understand what a vertical stretch and shrink does to a graph. It's the raising it, lowering it, or stretching and shrinking it. Understand where the vertical stretch-shrink factor is in an equation, and understand how to find a vertical stretch-shrink factor from a graph. So how do we actually find this number? Our vocabulary is the stretch, making a picture or graph look taller. Shrink, making a picture or graph look shorter. Stretch-shrink factor, the number you multiply by to cause the parent function to stretch or shrink. This is the actual number that makes it taller or shorter. We're going to be looking at two main functions. The first being absolute value, and the second being a quadratic. Here are the vertex forms of them. We've seen these before. Obviously, the vertex is shown with our h and our k. What we've learned in the past is that if the a value is positive, we're going to open up. We're going to get that up-facing parabola or up-facing v for absolute value. If the a value is negative, we're going to get the kind that's going down, so that downward-facing u. A, though, up till now, we've just been given what the a is. A lot of our problems have had an a value of 1. And 1, when you multiply with it, doesn't stretch or shrink. But any number other than 1 or negative 1 will stretch or shrink it. So this is our stretch-shrink factor. What we want to do is figure out ways to find it and understand how to use it. A is the stretch-shrink factor. If a is greater than 1, that means that it's going to stretch. It's going to be bigger. And remember, we're not worried about negatives here because negatives are dealt with how it opens. It's going to look longer or taller if our a value is bigger than 1. Whether it be a negative 2 or a positive 2, it's going to stretch it. Whether it stretches it down or stretches it up depends on the negative or positive. Shrinking is any number that's less than 1. So any decimals or fractions that are smaller than 1, like 1/2 or 0.5 or 0.25 or 0.3 or 1/3, any number smaller than 1. So one of the keys for doing this is actually being able to find what that stretch-shrink factor is. What we have here is a little table that we're going to use to try and figure out the stretch or shrink factor. I have a parent function of absolute value and a stretched function of absolute value. In this one, we're stretching by a factor of 2. What I want to show is how we found this 2. I already have the table all drawn out, so I'm just going to show you how we find these values. Now, focus on this as being how far we move from the vertex, not the actual values. So what we start with is this vertex for the parent function, and we want to know the x distance from the vertex. So we're going to move 1, 2, 3 places to the right or to the left. I'll typically go to the right. So here we're just going to move 1 to the right. And then what we want to know is how far up do we have to go from that vertex? And that's our y value of the parent. So from this, I've got to go up 1. That's where these two 1s come from. I went 1 to the right, I had to go 1 up from the vertex. The new says I have to go 1 to the right, but then how far up do I have to go? So I'm going to go 1 to the right, and then I'm going to go up 2 before I hit my function. So this is a value of 2. Now, we then take our new y and divide by the parent y to get our stretch-shrink factor. This is 2 divided by 1 gives us 2. We should always probably do this at least twice to make sure that our math is working out. So this time I'm going to go right 2 spots. 1, 2 from the vertex, 2 to the right from the vertex. And then I've got to go up 1, 2 before I hit the function again. That's where this 2 comes from. Do the same thing with the stretched. I'm going to go right 2, 1, 2. Then I'm going to go up 1, 2, 3, and 4. And now I'm here. So I've got 4 right here. I'm going to take 4 divided by 2. Both give me 2, which is my stretch shrink factor. So now I'm going to show you how to do this on absolute value and quadratic equations. So what I have here are 2 graphs, one being a absolute value, one being a quadratic. We want to find the equation of each. Well, the easy things are finding the h, the k, and whether the a value is negative or positive. The hard part is finding the stretch or shrink factor. So that's what we're going to focus on here. Obviously, vertex here is 0, 3. So I'm going to put 0 in for h. I'm going to put 3 in for k. Okay? This one is moving up, so our a value is going to be positive. Don't need a plus sign in front of it, but if you want to put one, that would remind you, but this one we're just going to leave. What we now need to figure out is a stretch or shrink factor. So, our vertex of the parent is always 0, 0, so that makes it pretty easy to figure out what we should get. We just take in our x distance and plop it in for x. We can find our y. So really, it's all about how far we have to move this one. So to get to my next nice point, which is right here, I have to move 3 times. 1, 2, 3. So I'm going to go an x distance of 3. Then for my new, I will go up 1. So now I need to know the parent y. So I'm going to take 3, put it in for x. Absolute value of 3 is 3, so I have that there. New divided by parent, 1 divided by 3, is the fraction 1/3. So it looks like my stretch shrink factor is 1/3, meaning this one's been shrunk, which makes sense when we look at the graph. It looks like it is shorter and wider. So I'm going to do this again. This time I've got to go 6. 1, 2, 3, 4, 5, 6. And I've got to go up 1, 2. 2 over 6. Or 2 here, 6 there. So then I'm going to take this 6, put it in for x. Absolute value of 6 is 6, so my y value is 6. I've got 2 over 6. 1/3, 2, 6 is really, both are 1/3, so that's my a value. Stretch shrink factor of 1/3 for this. It's been shrunk. The quadratic takes a little bit more work because the parent function is not as straightforward as absolute value. What we have is, now the vertex is right here at 1, 1. So I'm going to put that in for my h and my k. So I've got 1 and 1. This one is facing down, so we know that it's going to be opening down, which means that our a value should be negative. Okay, so now all that's left is to figure out what that a value is exactly. So we need to look at how far we need to move from the x. So I'm going to go right 1, and then I can get to this point right here. So the key is that the distance I moved is 1. It doesn't matter that I'm at a value of 2. I had to move 1 to the right. It's how far you move, not the actual value. So then from here I've got to move 1, 2 down. So that's a 2. I don't care about it being down because I've taken care of that right there. That negative means we're going down. So this is still 2. I need to figure out the parent y. Well, the easiest way for that, take your x distance, put it in for x, and do the math. So 1 squared is 1. This value is 1 here. We get 2 over 1. So it looks like we have a stretch factor of 2. Let's try it again, make sure we get the same thing. So this time we're going to go an x distance of, well, we're down here. So I've got to go 1, 2 it looks like. And it's 1, 2, 3, 4, 5, 6, 7, 8. Looks like I had to go 8 down. So this is a 2 because I went 2 to the right. This is an 8 because I went 8 down. Remember, I don't need a negative 8. There's my negative. Then what we've got is we've got to figure out the parent y. Well, I just take my 2, put it in for x. 2 squared is 4, so this value should be 4. So what I've got is new 8 divided by 4. 8 over 4 is 2. Both of them are 2, so my a value here is 2. If you notice, this way of finding our stretch shrink factor is very similar to when we were finding our basic constant with lines. We were taking a new y divided by an old y, and we were looking at the change there. This is the same thing. Our new y is from our transform version. Our old y is from the parent version to try and figure out that constant. If there's any part of this video that you didn't understand, please re-watch it again and come with any questions, class. Thank you.